Hi, I'm Carmen ANDERT with the GRCC Math Department. Today we're going to be talking about simplifying cube roots. The first thing I want to talk about is perfect cubes. So some cube roots simplify completely. For example, the cube root of 8 is 2, and the cube root of negative 27 is negative 3. So the first thing you need to do to master simplifying cube roots is to make sure you memorize the first several perfect cubes. So positive numbers, we have 1, 8, 27, 64, 125, 216, and of course it goes up from there. And then you have the opposites of those numbers, the negatives. Okay, now what if you need to simplify the cube root of a number that's not one of those perfect cubes? So if it's not a perfect cube, the cube root will not simplify completely. However, you may be able to simplify it somewhat. If you can factor the number using a perfect cube, then the cube root can be simplified using the multiplication rule for radicals, which says that the cube root of a number a times a number b is the same as the cube root of a times the cube root of b. Here's our first example. Suppose I want to simplify the radical. I'm looking at the cube root of 108. So what I'm thinking is, which of those perfect cubes goes into the number 108? And I know that 108 is 27 times 4. That means that the cube root of 108 is equal to the cube root of 27 times 4. And then the multiplication rule for radicals says that I can take the cube root of 27 and multiply by the cube root of 4. Now this helps because the cube root of 27 simplifies down to the number 3. So I end up with 3 times the cube root of 4. For our next example, we'll simplify the radical, the cube root of negative 128. Again, I'm thinking about what perfect cube goes into negative 128. And I know that 128 is 64 times 2. So I'm thinking of this as being the cube root of negative 64 times 2. Then I can split this up using the multiplication rule for radicals. And then the first cube root simplifies. I know that the cube root of negative 64 is negative 4, and the cube root of 2 doesn't simplify, so I just keep it there. The next thing I want to talk about is cube roots with variables. So remember, a perfect cube is any number or any expression raised to the third power. So here are some examples. I have x to the third power. That's a perfect cube. If I take x squared and raise it to the third power, we get x to the 6. X cubed raised to the third power is x to the 9th. X to the 4th raised to the third power is x to the 12th, and so on. So we're noticing that any variable raised to a power that's a multiple of 3 gives us a perfect cube. Now, if the exponent is a multiple of 3, we can simplify the cube root by dividing the exponent by 3. So looking at the same list we had above, if I want the cube root of x to the third, we take the exponent 3, divide by 3, we get 1, and our answer is x to the first power, which of course is just x. If we want the cube root of x to the 6, we think 6 divided by 3 is 2, and so our answer is x squared. Similarly, the cube root of x to the 9th is x to the 3rd, the cube root of x to the 12th is x to the 4th, and every time we just divide the exponent by the number 3. All right, so here's a more complicated example. Suppose I want to simplify the cube root of 750 a to the 9, b to the 13.
The first thing I'm going to think about is what perfect cube goes evenly into the number 750. I know that 750 is 125 times 6, and 125 is a perfect cube. Next, I'm going to look at a to the 9. Because the exponent 9 is a multiple of 3, I'm going to keep that with the first part. And then I'm going to look at b to the 13. Now 13 is not a multiple of 3, but I can write b to the 13 as b to the 12 times b, so that I'm keeping a multiple of 3 on the first factor of b. Then I can split up the cube root. So I have the cube root of 125 a to the 9, b to the 12, multiplied by the cube root of 6b. Now that I've split it up this way, the first cube root simplifies. The cube root of 125 is 5, and then dividing each exponent by 3, we get a to the 3rd, b to the 4th. And then the cube root of 6b does not simplify, so I leave it just like that.
For our last example, we'll simplify the radical, the cube root of negative x to the 5th, y to the 6th, z to the 10. So the constant that I have under this radical is a -1, and I know that -1 is a perfect cube. So I'm just going to leave it right there for now. Now I'm going to look at x to the 5th. The exponent 5 is not a multiple of 3, and the largest number less than 5 that is a multiple of 3 is 3 itself. So I'm going to write x to the 5th as x to the 3rd times x squared. So I'm keeping the perfect cube factor and the other part separate. Now looking at y to the 6th, 6 is a multiple of 3, so I'm going to put y to the 6th in the first factor. And looking at z to the 10, 10 is not a multiple of 3. The largest multiple of 3 less than 10 is 9, so I'm going to put z to the 9 in the first factor, and then one copy of z in the other factor. Now we can split this radical up, so I can do the cube root of -1, x to the 3rd, y to the 6th, z to the 9, and separately from that, I can do the cube root of x squared, z. Now, the first cube root simplifies completely. I get -1 x y squared z to the 3rd, again dividing each exponent by 3. And then I multiply by the cube root of x squared z that does not simplify. I hope this has helped you learn how to simplify cube roots. Good luck in your math class.